Hello students, welcome back. Uh, I have told you in the last uh, video that we will be doing some more numericals on de Broglie's wavelength to find out how it relates to our day-to-day life, and are there any inferences that we can get from de Broglie wavelength of quantum mechanics in our day-to-day life. So we will just be checking out. Okay, so suppose there is a particle or a ball or some matter thing which has a mass of 1 kg. Let's say we have been given mass of 1 kg and the velocity of 1 meter per second. So this is something of 1 kg going at a velocity of 1 meter per second. So this example is from our day-to-day life. And let's check out how the quantum mechanical uh, phenomena applies to it, right? What are the dimensions and what are the magnitudes that we are going to find out if we apply quantum mechanics on our day-to-day life objects. So okay, we have to find out the lambda. So how do we uh, find out the lambda of a particle? So that is given by de Broglie's formula. Okay, so we have to find out the momentum, right? So h upon p is mass into velocity. So we have been given mass and velocity. So this question is going to be very simple, but the ramification that we are going to get from it can be startling. Okay, so lambda is 6.6 into 10 to the power minus 34 because h is that value and m is 1 kg into velocity is 1. So lambda for a particle of mass 1 kg going with a velocity of 1 meter per second is coming out to be 6.6 into 10 raised to power minus 34 meters. So in your day-to-day life, are you going to see the wave nature of matter particles? So the answer would be very difficult, no, almost impossible. So no is the answer. If the question is, can we see the de Broglie wavelength of matter particles in our day-to-day life? Okay, we cannot see the de Broglie wavelength because the magnitude is very small. The lowest magnitude that we are at present can see through our atomic field microscopy is about of 1 angstrom. Okay, so 10 to the power minus 34 you cannot see with even the latest technology. Okay, um, so then the question arises is, so what should we do if we cannot apply quantum mechanics here? What should we apply? So our day-to-day life would be handled by the Newtonian mechanics, classical mechanics. That would be sufficient to handle this type of question. That means matter is particle type in day-to-day life. So what is the use of quantum mechanics? Quantum mechanics is used when you are going to analyze the electrons or atoms. Okay, So in the small realm, where the mass is very small, see, if the mass is place of 1 kg, mass would have been of electron. So mass of electron is of the order of 10 to power minus 31 kg. So this, when you apply this thing in this equation, then you get a significant answer for lambda. But if you apply it on day-to-day objects, you won't get a significant lambda that you should be considered about. Okay, so that's the point. This numerical is one of my favorite because it gives you an idea why we are using classical mechanics or Newtonian mechanics in our day-to-day life, and why they teach you classical mechanics when we already know that the full picture would become clear with quantum mechanics. So the point is, day-to-day life, quantum mechanics would not give you any result that would be of use to you. Okay, so classical mechanics would be sufficient to give answers here. Okay, thank you. See you in next numerical.